Hi guys, myself Dr. Hemavati Patil, Assistant Professor of Mathematics, Government First College, Manhali. Welcome to session 8 on ordinary differential equations. In this session, we are going to study about the Clairaut'S equation. So first let us see about the definition of a Clairaut'S form. The equation of the form y is equals to px plus f of p is known as Clairaut'S equation. So if it is in this form, to get the general solution of Clairaut'S equation y is equals to px plus f of p, we have one method here. So that is, let us differentiating equation 1 with respect to x. Then we have dy by dx. So this is dy by dx is equals to p plus, it is product of two functions, p as it is root of x is 1. So then plus second function x as it is root of p is dp by dx plus f dash of p into dp by dx. So we know dy by dx is denoted by p. So p is equals to p plus x dp by dx plus f dash of p into dp by dx. So here on both sides we have p. So we can cancel this p, or we can take on one side and we can cancel. So now we have here dp by dx is common. So x plus f dash of p into dp by dx equals to 0 remains. So this implies dp by dx equals to 0 because we don't have any dp by dx in this term. So we can consider only dp by dx equals to 0. So this implies p is equals to c. So now you have to substitute this p equal to c in given equation. Given equation is in the form of y is equals to px plus f of p. No, you just substitute p equals to c, you will get y is equals to cx plus f of c is the required solution. So here to get the general solution, you have to put here just, you have to replace p by c, you will get the general solution. So hence the general solution of Clairaut'S equation is obtained by simply replacing p by c. So again we have one more solution, so that is a singular solution. So for that we have one note here. So from this second equation, we get x into f dash of p. Here we have here x f dash of p into dp by dx equals to 0, no? So from this we can get here x f dash of p is equals to 0. Take this one as equation number 4. If we eliminate p between equation 1 and 4, this is the method of finding a singular solution. So that is here we have to eliminate p between equation 1 and 4, and we shall arrive a solution which is in the form of arbitrary constant and is not a particular case of general solution equation 3. So solution is known as singular solution of a Clairaut'S equation 1. So and this, how we know how to get, now let us see how to get this singular solution. So to obtain equation, this equation 4 can be obtained from equation 1 by differentiating partially with respect to p. That is x plus f dash of p is equals to 0. It is not so important. I will tell you how to get the singular. Let us see the method of solving Clairaut'S equation. So first one is to obtain only 2 points you have to remember. To obtain the general solution, just replace p in the given equation by c. If the given equation is in Clairaut'S form, to get the general solution, you just replace p by c. And second point is to obtain the singular solution, you just differentiate the given equation partially with respect to p and eliminate p between the given equation and the equation so obtained. You will get the singular solution. So it is also very easy. You just differentiate equation, given equation partially with respect to p and eliminate p between equation 1 and the equation obtained here. So you will get the singular solution. Only 2 points you have to remember. It's very easy it is. Let us take one example so that you can understand it very easily. Find the general and singular solution of y equals to px plus sine inverse p. First point is it should be in the Clairaut'S form. So of course it is in the Clairaut'S form only, because the Clairaut'S form is y is equals to px plus f of p. So take this one as equation number 1. The given equation is Clairaut'S form, because you know the Clairaut'S form is y is equals to px plus f of p. Let us compare these two. So here we have px plus f of p, that is sine inverse p. It is a Clairaut'S form. So now the general solution is obtained by just what here, replacing p by c in the given equation. So that is y is equals to cx plus sine inverse c, which is the required general solution. And similarly, this is the general solution. It's very easy to get the general solution. What you have to do is you just replace p by c in the given equation. Next, to obtain the singular solution. So I have told you in the method, you just differentiate the given equation partially with respect to p. So you will get here derivative of y with respect to p is 0, partially it is. Partially with respect to p means only have to consider p as the variable, remaining are all constants. So here y is constant because we are differentiating partially with respect to p, and here p is variable and x is constant. So derivative of p with respect to p is 1 and this x remains as it is, and derivative of sin inverse p is 1 divided by under root of 1 minus p square. Take this one as equation number 2. So here we want to eliminate p, no? So for that you just simplify this one. So take LCM, under root of 1 minus p square is LCM, cross multiply x into root 1 minus p square plus 1 is equals to 0, and denominator becomes 0 here, and you take this minus 1 in this plus 1 in this RHS, it becomes minus 1. So what we have, under root of 1 minus p square is equals to minus 1 by x, or squaring on both sides we have 1 minus p square is equals to, after squaring it becomes plus 1 minus 1 divided by x square. So we want p square, no? You just take here on this side p square is equals to 1 minus x square, take LCM, it becomes x square minus 1 divided by x square. So this implies p is equals to under root of x square minus 1 divided by x. So this value of p you have to substitute in equation 1. That is equation 1 becomes, that is a substitute in equation 1 here. Substitute in equation 1. So equation 1 is y is equals to, we know y is equals to px. So that is here we have to substitute this value, no? Y is equals to px, p is root x square minus 1 divided by x into x, x get cancelled, we have only simply this under root of x square minus 1 plus sin inverse p is root of x square minus 1 divided by x. This is the required singular solution. So this is the singular solution it is. Let us take one more example so that our concept will be clear. Find the general and singular solution of y is equals to px plus a divided by p. So first you write this equation as it is, y is equals to px plus a divided by p. It is in the Clairaut'S form only because the Clairaut'S form is y is equals to px plus f of p. So it is in that form. So to get the general solution, you just replace p by c. So you will get y is equals to cx plus a divided by c. So now to obtain the singular solution, we know the method is differentiating equation 1 partially with respect to p. Let us differentiate this equation 1 partially with respect to p. So again derivative of y is 0 and derivative of px is simply x because x is constant as it is, derivative of p with respect to p is 1, then a is constant as it is, derivative of 1 by p is minus 1 by p square. So it is x minus a divided by p square. This implies here we want to eliminate the value of p. So this implies a divided by p square is equals to x. So this implies cross multiply this one, p square equals to a by x, or we have p is equals to root of a divided by root x. You just substitute this value of p in equation 1, we get y is equals to, our y is what? Given equation is y equals to px plus a divided by p, no? So p is root a divided by root x into root x plus next is what? What we have? A divided by p. A divided by p is root a divided by root x. So this implies y is equals to root x. Here x means it is root x. I hope all of you know this one. This is x is nothing but here root x into root x. So one root x get cancelled. So only root x remains here. It is root a into x plus if you take reciprocal. If you take reciprocal it becomes what here? It becomes, see this one, a divided by root a divided by root x is a into root x divided by root a. Again we know a is root a into root a, this one, and divided by root a into root x. One root a get cancelled. So what else remains? Root a into root x. So this one is root a into root x. What we have? Root a into, under root of ax into under root of ax. It is 2 times it is. So this implies here y is equals to 2 times of root of ax, which is the required singular solution. I hope all of you got this, how to find the general and singular solution of a Clairaut'S equation. It's very easy. You just replace p by c in P by C in given equation to get the general solution, and differentiating given equation partially with respect to P to get the singular solution. Let us take one more example. Find the general and singular solution of a square minus x square into p square plus 2xyp plus b square minus y square equals to 0. Here it is not in the Clairaut'S form. First you have to convert this one into Clairaut'S form. After that we can solve this one. So first you have to the given equation as it is. So now here let us open this bracket. It is a square p square minus x square p square plus 2xyp plus b square minus y square. See here, this is 2xyp is there. So how to combine these two terms here? We can take here this y square in this side. So it becomes take this one a square p square plus b square as it is. Take all the terms in this side. So it becomes y square minus 2xy plus x square p square. It is in the form of a square plus b square minus 2ab. So this is nothing but y minus xp whole square. So this implies y minus xp whole square is equals to it is equals to a square p square plus b square. So after taking square root it becomes plus or minus under root of a square p square plus b square. We want y, no? So take xp in this side. So it becomes y is equals to xp plus or minus under root of a square p square plus b square. This is the Clairaut'S form. So you know Clairaut'S form is y equals to px plus f of p. And the general solution is just replace p by c in the given equation in the Clairaut'S form. So you will get y equals to xc plus or minus under root of a square c square plus b square. So again here, otherwise we can replace in, this is the simplified form of the given equation. Given equation is nothing but a square minus x square into p square. In place of p square just replace c square plus 2xyc plus b square minus y square equals to 0, which is the general solution. So now to find the singular solution, I told you differentiate the given equation partially with respect to p. So this is our given equation only here. In place of p it is c. We replaced here c. So a square minus x square is constant and derivative of p square is 2p. Then plus 2xy as it is, root of p is 1. So and this one is constant, its value is 0. So this implies here we want to find the value of p, no? So it is 2a square minus p square, p is equals to minus 2xy. To get cancel, p equals to minus xy divided by a square minus x square, or p is equals to here now substitute this value of p in the equation 1. So that is a square minus x square into p square. P square is here. After squaring this one, see here I have taken minus sign common in the denominator and it becomes x square minus a square. So it is x square a square y square divided by x square minus a square whole square, and 2xy into x divided by x square minus a square plus b square minus y square equals to 0. You just here one term you will get cancelled, a square minus x square get cancelled. So that is only one term remains. So I told you here x square minus a square whole square is there. This I have written here taking minus sign common, it is a square minus x square. After squaring it becomes plus. So this is nothing but here x square minus a square is same as, this is the same as a square minus x square whole square. So one term will get cancelled, only one term remains, and here also same thing. Here take LCM. So it is after simplification it becomes minus x square y square divided by a square minus x square, and this term as it is here. And then after take LCM and simplify. So this becomes after simplification you will get here b square a square is equals to x square b square plus y square a square. So dividing this throughout by a square b square, you will get x square by a square plus y square by b square is equals to 1, which is the required singular. So this is just simplification. So this you can do yourself by your own method. So this is all about this today's session. Thank you very much for learning this Clairaut'S equation. Thank you. Here I have some more examples. You can solve these examples yourself. Just I'll give you the notes. It is just you take this. If you want, you can take screenshot and you can solve yourself. So this is one more example I have given you, and this is the solution. You just take the notes. It is just like a notes, because explaining all these examples is not easy. It will consume more time. So and if the video is too long, it is difficult to upload also. You just go through these examples yourself. By taking screenshot you can find these you can get the notes. So these are some more examples I have given you. You just take notes of this one and take screenshot, and I have given some multiple choice questions also. You just note these multiple choice questions also, and I have given answers also. You just take, these are like assignments, multiple choice questions. You solve yourself and you will get the answer. Thank you.